calculator. So now I will show how I derive the temperature profile and rate of heat transfer on the spherical system. So my assumption is it is one-dimensional respect to our axis, and it is no heat generation or no heat generated, which means the G is equals to 0, and steady state condition it shows 0. And also we can cancel out this one because we are dealing with the R axis only, R direction. So from here we can get the equation of this. It is equals to 0 since it is in steady state condition. So move 1 over R squared to the right side, it will give 0. And from PDE we can convert to the ODE. So we will do the first integration and I get this equation, and for second integration we find TR equals to this equation. Next, for the boundary condition is R equals to R1, R equals to R2, T equals to T1, T equals to T2. When apply the boundary condition, I get T1 equals to this equation and T2 equals to this equation. So we will solve simultaneous equation in order to find C1 and C2. Okay, so the second equation will minus with the first equation. So for C1 I get this equation, and C2 I get this equation. To solve the TR, we substitute back the value of C1 and C2 and we get this equation. This is for the temperature profile. For the rate of heat transfer, using the equation of negative area multiple with a constant and also the dt over dr. So area of sphere is 4 pi r squared, and then we will integrate the equation here, and lastly we will get this equation. The top one will be the driving force and the bottom one will be the resistance.